Welcome to this module on additional career-oriented data visualization topics like A/B testing, the executive dashboards, the real-time monitoring, and the data journalism. So these four topics they represent the practical skills that can separate the learner from the entry-level analyst to a senior data professionals. So they come in for every technical interview questions for a data science role. So let us move deep into about the different sorts of other data visualization topics, which is very important. So the A/B testing visualization, it helps us to design the experiments and communicate the results with clarity and with statistics. The executive dashboards, they help to build the dashboards that CEOs, VPs, and the board members what they want. The real-time monitoring will help us to build the system in which you can watch the live data streams and alert whenever something goes wrong. Data journalism concepts will help you like how to tell the data stories for the public audience, combining the rigor with the accessibility. So each section has got its real world examples, design principles, and career specific guidance. So let us move into it. A/B testing visualization. This A/B testing can also be called as split testing or controlled experimentation, which is a gold standard for the causal inference in products and marketing analytics. So rather than observing the correlation and hoping, like A/B testing gives you a real thing, like controlled evidence that intervention X which causes an output Y. So, but the analytical challenge is only half the problem. The other half is communication. So, how do you show a non-statistician like what statistical significance actually means, and how do you visualize uncertainty? How do you present a null result without its feeling like failure? This is all matters here in A/B testing visualization. So in this session, we'll cover the core statistical concepts, the best visualization patterns for the A/B testing results, and the career critical skills of presenting these findings to the product and the business stakeholders. Let's make sure we are all working from the same statistical foundation before we look at the visualization. The five-step workflow is non-negotiable. Skipping any step introduces a bias. So let us look into each and every step one by one. So step one is hypothesis. So state it before you look at any data. The hypothesis must be falsifiable and include a minimum detectable effect. So you cannot define success after you see the result. And step two is about the sample size calculation. This is where like most of the amateur experiments fail. You cannot just run the test until you see the results you like. So we have to calculate the required sample size in advance before using the expected effect size, the significance level, and the statistical power. And step three is about the randomization. So truly random assignment is what that makes the A/B test very casual. Like if the groups differ on any systematic dimension, your result is going to be confirmed. Step four is a run to completion. So stopping early is the number one source of false positives in business experiments. So the infamous picking problem is that will run until you hit your pre-calculated sample size. And step five is we have to analyze it properly. So p-value alone is insufficient. Always we have to report the confidence interval, the effect size, and the business interpretations. The four key terms at the bottom are what that every stakeholder question will refer. We have to know them cold. Let's talk about how to visualize this A/B test results. Because the default approach, which is just printing the p-value and the percentage left fails your audience, right? So the confidence interval plot on the left is the gold standard for the stakeholder communication. So each metric is a row. The dot is a point estimate, the absurd difference. So here you can see that. The bar is a 95% confidence interval. If the bar does not cross zero, the result is statistically significant. So this view shows the direction, magnitude, and the uncertainty simultaneously. So a stakeholder can see at a glance what is the revenue per user, the bounce rate, whether it has improved, or whether there is any uncertainty. So this is a complete figure that gives you about the statistics, which can be used by the stakeholders or the business professionals. So here the left waterfall chart is for when you used to communicate, when you wanted to use this to communicate in business terms, you can use this left waterfall chart. So rather than the click-through rate, like it is increased by 3.8%, you show that you can expect this change to generate an additional like 240 thousand euros per month. So that is what gets a decision made, right? So the SP RT monitor, this is for engineering teams who is running a continuous experiments. It is mathematically valid to stop when a boundary is crossed, unlike a standard t-test where peaking is statistically, which is dishonest one. And the null result visualization is critically underused, like showing a null result with a tight confidence interval is actually very valuable information. It says that we tested this properly and genuinely it does not work. So this is about the different mm, visualization, the patterns that you have in your A-B testing. And section 2, let us now see about the executive reporting dashboards. So this is arguably the most career impactful skill in this module. Like executive dashboards are what your CEO or CFO and the board members, what they see. So they shape like how leadership perceives the entire data function. A well-built executive dashboard is a difference between the data team that is seen as a strategic partner and one that is seen as a reporting service. The challenge is very unique here. Like executives have limited time, they have low tolerance from ambiguity and a strong preference for narrative over explorations. So they need answers, not tools to find answers themselves. So we'll cover up about all these core design principles, what to include and what to cut, the structure of an effective executive view, and how to handle the inevitable question like why does this number look different from the number in the board pack. So let us move deep into it. So let me walk through the 6 principles and then the anatomy of the well-structured executive dashboard. The first principle is one screen, one decision. An executive dashboard that tries to answer every question answers none of them clearly. State a central question in the title and design everything to answer that question. Principle 2 is lead with exceptions. Red amber, green traffic lights are the fastest scanning pattern for a busy executive. So they see what needs attention without reading any numbers. Principle 3 is always show trends. So a standalone number is almost meaningless. Say euro 4.2 million, is that good? Add up 12% versus last month above target and it becomes a decision. Principle 4 is one number per KPI. The executives track 5 to 7 strategic KPIs, so everything else is supporting detail. Principle 5, you have to write the insight. Your chart title is the most read element. You have to replace revenue by region with APAC revenue down 8%, driving 60% of the overall shortfall. Say principle 6, freeze the layer. The spatial memory is real. So when a CFO sees the same dashboard every Monday, their eye go beyond straight to the revenue card, the cost card, and the margin. So moving things around destroys that efficiency and erodes the trust. So the anatomy diagram on the right shows the recommendation zone structure, like the header, the KPI row, the primary chart, the secondary breakdowns, footnotes. So in that order, like every time it matters. So this slide shows a simulated CEO weekly revenue dashboard with live embedded charts. So let us look at the KPI row at the top. So here four cards. One is weekly revenue, the gross profit, active customers, and the target attained. So each shows the current value and the trend versus the last week. So you can see here, like the revenue is up, shown in green, and the gross profit is down, which is shown in red. No numbers are needed to scan the health state. The um, red tells the story instantly, right? So the primary chart is a revenue trend line against the target. So notice the title here. It is an insight. It is not a label. So revenue versus target, week 12 above prior week, still 4 pp below target. So this is making something very meaningful. The CEO does not need to read the chart to get the answer. The title itself is providing it. And the secondary chart on the right. So here it is a regional breakdown chart. So UK is the largest contributor. The APAC is smallest. So this immediately surfaces the follow-up question, like, is APAC the reason we are below the target? So this is the design philosophy, that every chart should surface the next question, not just report the current answer. So in the real deployment, this dashboards will refresh automatically that every day, and the CEO receives it in their inbox at every 7 a.m. in the morning. So the goal is that zero question that cannot be answered by looking at this one page. So this is something. Session 3 is about the real-time data monitoring. So in the previous sessions, we worked with the batch data that is collected, processed, and then displayed. So real-time monitoring is fundamentally different. Like the data is arriving continuously and the system must detect the problem and alert the right people before the impact compounds, right? So think of the system that we need is that a payment processing platform where fraud must be detected in milliseconds, an e-commerce site where a checkout failure must be caught before it affects 1,000 of customers, a hospital ICU where vital sign must trigger alert before the patient deteriorates. So the real-time monitoring dashboards are not an exploration tool, they are operational control system, and the design philosophy is completely different. So in this session, like, we are going to cover the technical architecture, the key visualization pattern for the streaming data, and how to design the alerting threshold that could minimize the false positives and the missed detection. Walk through the technical architecture and the visualization pattern for the real-time monitoring. So the architecture has got 5 layers. The first is data source. So anything that emits event, like from IoT devices or the application event streams, the database change, data capture, external APIs, the webhooks, all this produces data. Next is the message queue. Message queue is the backbone of the real-time system. Kafka, which is a dominant choice for high throughput applications, it can process millions of events per second. So it decouples the producers from consumers, it provides durability, and it allows multiple systems to consume the same stream independently. Next is about the stream processor. So this is a computation layer. The Apache Flink and Spark streaming performs the windowed aggregations, computing the average of the last 5 minutes of data, for example, in real time. Next is the time series store, which is a specialized databases which is optimized for the timestamp index data. The InfluxDB, it compresses the time series data 10x better than the standard relational databases. The ClickHouse can query a standard relational database, like it can query a billions of rows in milliseconds. Monitoring layer, the visualization and the alerting front end it is. The Grafana is the open source default, and the Datadog is the enterprise standard. Now let us see the visualization pattern. So the rolling time window chart with a selectable window or the primary view, and the engineers need to zoom in on the last 5 minutes to debug an incident and zoom out to the last 24 hours for the trend contest. And the dynamic thresholding alerting, like it is not going to be static. It is not static, and it is a professional standard. So if you alert every time the metric exceeds a fixed threshold, you create an alert fatigue. Anomaly detection using this rolling baseline dramatically reduces the false positiveness. And it can also make out the alert fires for the, you can make out the metric correlation heat map. And for the system with regional deployments, a world map with latency or error rate overlaid by regions, you can use it for geo-distributed status map too. Alert fatigue is one of the most dangerous operational problems in data and engineering organization. So when alert fires constantly, most of them are false positives, so the engineers start ignoring them. And then a real incident is missed because the team assumed that it was another false alarm. Like the alerting quality matrix, which is in the left frame, this is a decision problem with 4 outcomes. So you have to maximize the true positive. Um, the real issue will be caught. And we have to minimize the false positives, that non-issue that generate alerts, and minimize the false negative. So the real issue that is being missed out. So the 4 alert design rules are the practical implementation. So firstly, we have to set the threshold using the historical data. The 99% of the latency over the last 30 days is a defensible threshold. And second is about adding a minimum duration. The single spike above the threshold may be a blip. So a 2-minute sustained exceedance is a real problem. And third is about the multi-condition alerts, which can dramatically reduce the noise error rate above 5% and the traffic above 1,000 requests per second. So both the condition must be true simultaneously. And fourth is the group related alerts into the incidents. A cascading failure should produce one incident, but not 50 simultaneous alert, right? So the 4 priority tiers on the right defines a response escalation. Like not every alert needs to wake someone at 3 a.m. Only the P1 incident should do that. A final session is about the data generalization concept. So data generalization, it sits at the intersection of the analytical rigor and the public communication. So it is practically at the Guardian, the New York Times, the Financial Times, the BBC, and the ProPublica. But the skills are differently transferable to corporate communications, policy works, and the public-facing analytics roles. The core challenge is very unique, and you are communicating a complex data finding to a general audience that has no statistical background, limited patience, and complete freedom to click away. So this data journalism has produced some of the most impactful public work in the recent decades, from the Panama Papers investigation to the New York Times COVID tracking dashboard to the Guardian's inequality visualization. So in this session, we'll cover the key techniques, the ethical obligations, and how these techniques can translate into your career. So let me walk through the 6 core techniques and then the landmark projects that define the field. The first is FOIA data analysis. So most important investigative data stories start with the public record request. Learning how to request, how to receive, and analyze the government data sets is a career differentiator for a policy analytics and for public sector data roles. The geospatial storytelling. So maps that triggers an emotional response that bar charts never can. Seeing a COVID hotspot on the map on your own city is fundamentally different from seeing a bar chart of the cases, which is record. And record linkage, connecting the data sets that share no common key. The Panama Papers investigation matched names across 11.5 million documents using fuzzy string matching and network graphs. That is data engineering in the service of investigative journalism. And about the storytelling, the narrative form where the chart responds as you scroll through the story text. The New York Times, you draw it, and how the virus got out are the defining examples that we can give. The algorithmic accountability, investigating whether the AI system is discriminate. Like ProPublica's Compass analysis found that the recidivism precision prediction tool used in the US code has got a higher false positive rate for the black defendants than the white defendants. So that is data journalism as civil rights investigation. And the annotation first chart, that every chart has an insight written directly on it. The reader never has to interpret anything themselves, right? So the four landmark projects shows a range from a multi-tier multinational investigation to the real-time pandemic tracker Belden Weeks. So let's cover the tools and the ethical obligations and where the data journalism skills takes your career. So the tool breaks into three categories. The first is data wrangling and analysis. The Python with pandas and beautiful soup for web scraping. R's tidy verse for statistical analysis. The OpenRefine for cleaning the messy public data, and Tabla for extracting the tables trapped inside the PDF reports. And next is about the visualization and publishing, like D3.js for the custom interactive graphics, for Flourish and Data Wrapper for rapid embedded charts, and observable notebooks for publishing the live code stories. And Investigate and Geospatial, the like QGIS for geographic analysis, the Google Earth Engine for satellite imagery, the Chefi for the network graph visualization, and SCAPI for NLP on the large document collection. So the ethical obligations are non-negotiable in data journalism, that they should be in corporate analysis too. So you can publish your methodology. If you cannot show like how you arrived at your conclusion, the conclusion is not trustworthy, right? So we should not mislead, and we have to protect the sources, like individual level data must be anonymized before publication, and acknowledge limitations explicitly, stating that the data cannot tell you as a sign of the analytical maturity. It is not the weakness. So as for career path, these skills are not just for journalists, the policy analysts, communication team, like product analysts, anyone who communicates data to a non-technical audience, they can be benefited enormously from the data journalism train. So let me map each of the four topics to the career opportunities they unlock. A/B testing visualization is the most directly relevant to the product analyst and growth roles. So if you apply for any product or growth analytics role, then you will be asked to walk through how to design and analyze an experiment. So this is close to a universal interview question at companies like Airbnb, like Netflix, Booking.com, and any tech companies with the product. And the executive reporting dashboard is the most broadly applicable. Like every data function in every industry needs someone who can translate the analysis into an executive ready views, right? So the senior analysts and the lead roles specifically look for this executive reporting dashboards. So like the interview questions to prepare, like how do you reduce the ad hoc data requests from leadership? And next is about the real-time monitoring, which is most technical and the most valued in engineering adjustment roles, like ML operations, data engineering, for analytics engineering, and platform engineering all require these skills. So the question is like how would you detect a data quality issue in a live pipeline before it corrupts the dashboard? And about the data journalism, as we have spoke earlier, like It unlocks a unique career path, roles that exist at the intersection of analysis and communication. So the interview work can ask, like, show me an example of communicating something complex to a non-technical audience. So these three career tips at the bottom are worth emphasizing, like build a portfolio piece for each topic. You can practice explaining your work out loud and read the best practitioners in the field, like the FT, the Pudding, and the NYT Upshot. So let's bring the whole module together. The 5 takeaways, one per topic plus one synthesis point, is that the takeaway one, which I can give you, is the A/B testing, which is a statistical significance, is not enough. The report confidence interval and the effect size. A p-value of 0.04 on a 0.01% conversation left is statistically significant and completely meaningless. The executive dashboards can consistently build the trust. The executive who sees the same layout every morning develops a spatial memory for the dashboard. So this efficiency is valuable, you can protect it. So the takeaway 3 is a real-time monitoring, which can design your alert as carefully as you design your chart. And takeaway 4 is data journalism, like the obligation to show your work, acknowledge the limitation, and annotate the insight directly should inform all of your analytical communication. The takeaway 5 is the synthesis. These 4 skills together form a complete senior analyst profile. Like you can experiment rigorously, you can report to the leadership, you can monitor the production systems, and you can communicate publicly. So like the 4-week action plan on the right is concrete and achievable. Like every action uses free tools, so every action produces a portfolio artifact. So week 1 you can run a real A/B testing and write it up, and week 2 you can build an executive dashboard and test it with a 5-second rule, and week 3 is install the Grafana locally and set your first dynamic alert. Week 4 is publish a data story on a data wrapper and share it publicly. So these are not theory exercises, they are career investment. Thank you for listening.